AB Calculus, Notecard 39, Concavity. This is the 39th lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this Notecard series. Concavity, second derivative. A differentiable function is concave up if f of x is increasing at an increasing rate. And here we have a little piece of a curve decreasing at a decreasing rate. Here we have another piece of curve, f prime of x is increasing, or if f double prime of x is greater than 0. I'm going to make a little chart. And concave down if f of x is decreasing at an increasing rate. Here we have this little piece of curve increasing at a decreasing rate, a little upward curve, f prime of x is decreasing, or if f double prime of x is less than 0. So basically, concavity refers to if the curve is, so I'm drawing a curve up here, so we have this kind of motion here, and a portion of the graph where the curve is facing downward, like this piece over here that I'm circling, that would be an example of concave down. Okay, sometimes it can be abbreviated concave down. And this other part starting here that I'm now circling, where you have an upward bend to the curve, this would be example of concave up. Concave up part of a function f of x. And then we have these other pieces here, and we have a concavity test. I'm going to make a couple little analysis tools that will be helpful to us, one of which I've already demonstrated. If you have a function f, a function f prime, and then below that we put f double prime. Okay, let's get those here. Not too legible, but I'm going to put for f plus minus, up arrow, down arrow, and then concave up, concave down. And then underneath, and we have f prime is positive when the underlying function is increasing, and f prime is negative while the graph of the underlying function is decreasing. And then I'm going to put up arrow here and down arrow here. And finally, on this row, this third row, this f double prime row, we have plus and minus below the f prime of x increasing and decreasing. And that's what this is explaining, other items 1 and 2 here. And so this little chart that can be drawn up very quickly can be very helpful, and I use it all the time in making the analysis of what is going on. And so we're going to take advantage of this chart in these problems during this lesson. I'm going to invite the viewer to consider another thing that we're going to look at. Let me see if I can draw that a little more circular than that. I'm trying to draw a circle. Okay, that's just going to have to do. And what you have, it's if I draw like an XY coordinate plane, okay, XY, and this piece of curve here, so we're going to look at the piece of curve. So this upper quadrant, quadrant 1 of this circle, is going to be your f prime of x is negative, and your concave down also. Okay, so that's going to be this quadrant. Next quadrant here, the second quadrant, you are going to be increasing, at least f prime is increasing, but the downward convex of the curve means that we're concave down. Now for this lower left, we are decreasing from left to right, so that's going to be minus here, but we are going to be concave up. So the little piece that we put in place, and this is going to be more helpful really when we actually sketch the functions. And finding this one on the lower right is going to be both increasing, or f prime of x positive, and concave up. And if you look carefully, you can see how this is going to be consistent with the drawings here. Okay, we have increasing at an increasing rate, right? That's going to be this piece right here, and so on for all the pieces. Okay, decreasing, concave down, increasing at an increasing rate. Anyway, I don't know if all these pieces are right, but this definitely is here. Okay, concavity test. For a function whose second derivative exists, if f double prime of x is greater than 0, then f of x is concave up, or above the tangent line. So we have, making another sketch here down below, if we have this concave up graph here, any tangent line that we draw is going to have f of x above that tangent line where the thing is concave up. And for concave down, I'll draw concave down, any tangent line is going to be above the bulk of the curve there. So that's all this is saying for concavity test. Okay, let's go over some pieces that are going to help us with the analysis. For the graphs of 1 and 2 below, determine the intervals where f is concave up and justify. And here we have f prime of x. And so I'm going to go ahead and draw the little chart here. In fact, I'm going to draw it in the upper right here. So we're going to put f prime, and f double prime. Okay, again, plus minus, up arrow, down arrow, and concave up, concave down. And then below an f prime, we put plus minus, and then arrow up, arrow down. And lastly, under f double prime, we're going to put plus minus right here. So we can see with this plus minus where f double prime is what's happening in the f prime and also in the f function. So here we have f prime of x and concave up and justify. Well, we are concave up where f prime of x is increasing. Okay? So we are concave up, and there's the concave up right here. Okay, that's this u, upward u. And so we're going to see f double prime being positive and being concave up. So we see that I'll just justify. F is concave up on, and we could just make some intervals here, right? And we can leave a bunch of space here. And why? Because f prime of x is increasing. Okay, INC. So now we'll just see where f prime of x is increasing. We see that f prime of x is increasing from x equals -1 all the way up to x equals 1. And also from where there's a u for union, also from where x equals 3 to x equals 5. And again, the justification because f prime of x is increasing on these intervals. And so that's the answer, and that's the justification, and that's using our little chart in the upper right. Okay, next, concave down and justify. And so we have this time, instead of f prime of x, which we were looking at over here for number 1, number 2, we're looking at f double prime of x. And concave down and justify. Well, here we're looking at this third row. And for a third row, we're looking at where f double prime of x is negative. Well, the places we see that f double prime is negative is this interval here that I'm circling, and also this interval here between C and D. So we will say F is concave down on intervals from A to, it looks like this is the origin here, so we'll say A to 0, and also from C to D. And I'm going to just write it below here, because f double prime is less than 0. Now see, we're using different things between problem number 1 and problem 2 to make our justification about concavity. So we're just looking at different dimensions of analysis, is one way of saying that. Okay, let's go ahead to our next problem, which is going to involve looking at a table. A continuous monotonic function f is defined on the domain, the closed interval from -3 to 3. It has some values listed in the table below. Also, f prime of x is continuous and has only one zero in the interval of -3 to 3. And that's going to be this one right here, right? That 0 right here is what they're speaking of. Determine the intervals for which f is A, concave up, and B, concave down, and C, determine the x value, if any, where the concavity changes. Okay. Well, I'm going to bring my little table into play here. We're going to have f prime, f double prime, and just use the analysis. So you can have plus minus, increasing, decreasing, concave up, concave down, and then for f prime we're going to have plus minus here, and then up arrow, down arrow, and then finally under f double prime we're going to have plus minus. So we are seeing okay, this f prime has 1 0. So f prime is coming down, and if we could draw a little sketch of this, okay, here, a continuous monotonic function is defined, okay? So f prime is starting here at 0.889, coming down to 0.75, 0.68, and that's going to be at -3, -2, -1, and at 0, we are at 0 right here. Okay? So this is what f prime is doing. Monotonic, coming down. All right, and then to the right of 0, where x equals 1, we are here at 0.68, and then we are at 2, we're at 0.75, and at 3, we're at 0.889. So we're going up like this. Okay? So this is going to be an estimation of f prime of x. And so I hope you can see that we are decreasing. So f prime is decreasing in the interval from -3 to 0. And so therefore, we're looking at this kind of piece here. So we will say f is concave down on from -3 to 0 because f double prime is decreasing. Okay, now f is concave up on 0 to 3, and why is that? Because f prime is increasing. So we're just using the justification they give. So that would be this piece I'm now circling here, right? Concave up on that interval. And determine the x value, if any, where the concavity change is justified. So the last thing I'm going to write is concavity changes from up, or actually from down to up at x equals 0. And why is that? Because f prime changes from decreasing to increasing at x equals 0. So there's the justification. And basically you're going to be learning to justify based on the evidence at hand. In this case, this table and what we can ascertain from what we see in this table. Well, that's all we have. Again, it's another layer of analysis. It's somewhat analogous to looking at the increasing and decreasing intervals. We're just taking it another level lower. I hope this has been helpful to you. Good luck, and thanks for viewing.